Hello, this is Deepak. Welcome to learning program Cisco Networking with Rajput. Today we are going to discuss about BGP. We will know how it works and how it is configured. So let us start. BGP is a path vector routing protocol and by default it uses ASs as the best path selection criteria. But there are many other ways to manipulate best path selection process that we will cover in upcoming videos. BGP is a protocol of internet. It is designed to be slow because you can imagine one flapping connection impact it can put on complete internet if the routing protocol is designed to be very fast, just like IGPs. So it is designed to be slow, and by default, its timers are 60 seconds and 180 seconds. 60 second is keep alive messages, and 180 second is hold timer. BGP works on top of TCP/IP protocol. What exactly that means? That means that it uses IP protocol, TCP/IP protocols mechanism that is connection oriented, and once that TCP connection is established, then BGP starts negotiation. BGP did not develop its own mechanism, three-way handshake, so it just relies on the TCP/IP protocol. So once that TCP session is established, BGP starts negotiation. Two things which are really important for us to confirm before we start configuring our devices. First thing is network layer reachability information must be there. If we want to have a BGP to be configured on two devices, then we must ensure that both of devices know how they can reach to the other device. And the another important thing is port 179, TCP port 179. This port should always be open whenever you need to configure BGP. This port should be open. If anyways this port is blocked, there will not be any BGP session. BGP will not come up, so you need to take care of that. By default, Cisco doesn't block any port on its devices. Let us move to next slide. BGP types. There are two flavors of BGP. One is IBGP, another one is eBGP. IBGP stands for internal BGP, eBGP stands for external BGP. So as the naming convention says, internal is something which is internal to one AS. External is something which is between two ASs. So whenever we have IBGP session, that will be within one AS. So any two devices, when they try to have a BGP session within one AS, that session will be called as IBGP session. And when two devices belonging to different ASs try to have a BGP session, that will be called as eBGP session. Now let us have a look at BGP peering types. And first is IBGP example. So in this, as I just explained, the AS will be the same. We always try to have the BGP session within one AS. So over here, our AS is 100. We have two devices, R1 and R2, and the network configured between these devices is 12.1.1.0/30. So let us have a look on live devices. We'll configure IBGP session. First, let us check the interface configuration. On the other end as well. Okay. And in the pre-checks, I just explained that NLRI information must be there. So I will try to ping the other end. If that's reachable, yes, that is reachable. So now we can start configuring BGP 100. Remote end is 100. See, the important thing again, I'm putting a lot of stress on it. Whenever we have IBGP session, the BGP AS number configured on the device and configured for the neighbor will be the same. So in this case, uh, BGP AS configured on the device is router BGP 100, that is AS number 100, and on the neighbor we are configuring as remote AS as 100. So that's common. So it's IBGP session. The router BGP 100 neighbor and remote AS is 100. Okay, hopefully we should see the BGP up now. Let's try to share the summary. So, BGP summary. So we have IBGP session established, and let us review the summary table. So this is the identifier. It it automatically selects it's a BGP identifier, router identifier, and by default it's a highest loopback IP address. If that is not configured, then highest physical IP address will be considered as the BGP router identifier. The next thing is local AS number. So over here, the AS number configured on this device on which we are testing or we are checking is AS number 100, and the BGP table version is 1, main routing table version is 1, and this is the neighbor IP address which was configured or we have configured, and this is version 4. BGP, both the PS negotiated and agreed to use BGP version 4, and this is AS number. This AS number belongs to the remote end device, and message is sent, message is received, message is sent, and table version is the one at very early stage when there is no update exchange. I mean, when just BGP comes up, so as the updates are exchanged, it will increment. So this is the time since BGP is up or down, and state and prefix. If there is 0, then we are not getting any prefixes being advertised by our neighbor. So whenever anything is being advertised from our neighbor, we will see the numbers over here. Okay, so let us check the another flavor of BGP, that is eBGP. We will try to configure the devices for eBGP. I will use both of these devices, so let me remove the iBGP configuration from the devices. Whenever you configure or deal with routing protocols, always be very cautious, because right now I am working in lab environment. That's why I can simply remove the complete routing protocol. I just say no router BGP 100, but this is not the best practice. You should not follow that in live environment. Whenever you are working in live environment, you should take ultimate caution before making any changes, because over there customer is directly impacted. If you put there is situation when you are working on PE router, and you if you issue the command no router BGP, all the customers on that particular PE router will go down. So always be cautious before you apply the configuration. You should specifically go for your neighbor, and then accordingly you should adjust. But over here I'm working in lab environment, so I can do that. I can remove the complete routing process because I know there is no impact. So let us configure eBGP, router BGP 100, neighbor is 2, and remote is 200. Okay, BGP already done. Router BGP 200, neighbor remote is 100. I should see BGP came up. Okay, see again the information is same which we discussed in IBGP. So let me try to. Okay, I have configured loopback one on this router and the interface loopback one. It's a slash 32 subnet. So I will advertise this subnet in BGP and we'll see if the other end device can see it. Okay, then the command to do that is network and mask. That's it. Hopefully we should see it. We see it. Okay. So see the difference when there was no update sent from the neighbor. The table version was 1. Now the table version is 2. And state and prefix received was 0. Now it's 1. Okay. So this is how we can configure eBGP and iBGP on our devices. Okay. Now it's time for quick question. How do you think BGP is different from IGPs in reference to neighbor configuration and prefix advertisement? Write down your comments in below comment section. Thank you for watching. Hope to see you again.